right. I think that was really pleasant music that it just played. It's my first time experiencing that, and well done, StreamYard.
It's a nice way to kick off, right?
Yeah. Just better than like, I think we're live. Can people hear us? But I think we're live, and I think people can hear us. There's like, I'm switching to the LinkedIn tab, and there's a delay, but I think it'll be good to go. So thank you everyone for joining today. We're very excited to chat about a very fun and spicy announcement Snowflake made about a new type of virtual warehouse. So that is the plan. I suspect we won't use the full hour. We'll see how many questions we get. I see we got like 28 people in the thing now, and that number is slowly going up. So I will share my screen and we can just get rolling here. All right. And we got that up. Okay, awesome. So for those who don't know, Jeff and I, we are two passionate members of the Snowflake community, and we also work at a very cool company called Select, which is a Snowflake cost management and optimization platform. But we're not here to talk about Select today. We're here to talk about Gen2 warehouses. So for a quick overview of what we're planning to run through today, I'm going to start by sharing a little bit of background on what Gen2 warehouses are for those who haven't seen any, who know nothing about them, and they're just coming to this for the first time. Talk a bit about the pricing behind them, because they are different than their regular virtual warehouses. And then where we're going to spend the meat of the time, or the bulk of the time, is on Jeff has pretty much been heads down, diving deep into these new warehouses and running a bunch of benchmarking tests. So we're going to spend a bunch of time summarizing the learnings we had there, the results, the interesting observations we saw, and then try and give you a very tangible set of takeaways that you can use to go and apply in your day-to-day if you are looking to either improve performance or optimize costs, which I think there's very few Snowflake customers or any data platform customers who like don't care about either cost or performance. I think most people care about both those things. So very, very relevant. I don't even think I introduced us properly, but for those I haven't met, my name's Ian. I'm the co-founder and CEO of Select. And then I'm joined by Jeff Skoldberg, who's been a longtime friend. And I don't know if people have followed him on LinkedIn, but he always, for a long time, I've highly respected all of the things he talks about, provides lots of helpful tips with both Snowflake and dbt. Jeff, when did you join Select? I'm like, feels like you've been here for ages now.
Yeah, I feel like it's less than a month ago, though. It does feel like it's been an eternity, but I think realistically, it was like the very end of April. So
okay, nice. So yeah, Jeff's joined us as a sales engineer, working with our customers and working with me to help provide useful information about what's going on in the Snowflake ecosystem. So without further ado, let's jump into it. Feel free to ask questions whenever. So I'll be keeping an eye on things in the comment section of LinkedIn. I think they appear. They're appearing here. So
yeah, they are.
Jeff's going to be doing most of the nice. Hello, Alejandro. Jeff's going to be doing most of the talking. He's the brains behind the operation and all. Keep an eye on the chat and see if there's interesting things you want to discuss as they come up. So what are Gen2 warehouses? For those who don't log into LinkedIn every day, which I respect and encourage, Gen2 warehouses are a new announcement from Snowflake. It's a feature that went into general availability on May 5th. For those who don't know, Snowflake has a feature release sequence where they'll put a feature in private preview where a limited number of customers can test it. If you know something's in private preview, you can typically reach out to your Snowflake account rep and ask for it, just for reference. After private preview, it then goes into public preview and then general availability. So I'm actually not even sure if these went into public preview. I feel like maybe they went straight into GA.
Yeah, I personally never heard of them until they were in GA. So that was
cool. It was pretty wild. And I think I think we just discovered them by reading the release notes, which is something we'll talk more about later. Snowflake's constantly putting up, putting out new announcements, and it's like drinking from the fire hose, which is a great thing as a customer. So, anyways, these went to GA on May 5th, so just over almost 2 weeks ago. And what the big deal is here is the virtual warehouse in Snowflake really sits at the core of everything you do. Every SQL query or even often Python jobs you run in Snowflake run on virtual warehouses. So it is the compute layer that is doing all the work for on top of your data. Why this is a big deal is they basically released a new generation of these things that run all of your jobs. The Gen2 warehouses take advantage of newer hardware that comes from the underlying cloud provider. So a virtual warehouse in Snowflake is really just a collection of like compute instances. So if you're on AWS, it's a bunch of EC2 instances. If you're on Azure, I don't even know what the equivalent of EC2 is on Azure, whatever it's called, but
it's just called a VM.
VM. Okay, there you go. So it's taking advantage of newer hardware offered by those cloud providers. But the cool thing is there's kind of underlying hardware improvements that happen behind the scenes. What's interesting with Gen2 Warehouse is actually a combination of hardware and software updates. So Snowflake has made a number of software improvements that are specifically targeted to this new hardware. And we're going to talk about this as we go through the webinar, where there's a range of improvements you get, and some of those will just be due to the underlying hardware improvements that speeds up all queries. But then there's going to be certain things that like give specific types of queries and even bigger boosts, which is really interesting. And then, as people have called out in the comments, it is important to note that this is Gen2 warehouses as of today are only available in AWS and in 2 regions. Big emphasis on for now, right? So Jeff, I think I forget what you were referring to somewhere, but you made a comment about like Snowflake's rollout of like features to new regions in the past. Remind me what that was.
Yep. So it was when they rolled out Snowpark Container Services. It was only available, I believe it was EU, or maybe it was even like Asia Pacific or something like that, but it was available like not in the US for about 2 to 3 weeks. And then boom, all of a sudden it was available everywhere. It happened very, very fast. So we're hoping that something like that happens here, where they're kind of kicking the tires on Gen 2 and then boom, overnight they roll it out to everyone.
Yeah. Okay, so yeah, keep that in mind. If you're not on one of these cloud providers, then oh, you know what? Someone just posted they're available in Azure East as well. So my slides are already out of date. That's amazing. Thank you for whoever posted that. I don't see your name in the StreamYard comments. So anyways, that's where it is. If you are working with very, very big data and using a 5XL and 6L warehouse, it's not available yet, but I think that is the minority. Okay, so on the whole, like, new warehouses, they run queries faster. Why not just use everything for these? Like put every workload on Gen2 warehouses? The simple answer is because they are more expensive. Snowflake, absorbs the cost or pays the cost of the underlying VM. So they have to charge more for this, offering this better hardware. So many people don't know about this, but there's this PDF essentially. Let me just try opening that. Perfect. Yeah. So this should be like on your wall if you're, maybe that's a bit extreme, but you should have this bookmarked. It's a very helpful guide. It's like the go-to place if you're ever curious about like how is something priced in Snowflake. You can click through the docs. I often just jump straight to that PDF. Partly because I'm a cost nerd, partly because it's like very comprehensive and very helpful. So this screenshot on the slide is straight from there. And what it's doing is showing the difference in pricing between the original warehouses, which I guess we call them like Gen 1. I don't know. I'm going to call them Gen 1. I'm going to try and make that a thing. Gen 1 warehouses are here, and then Gen 2 warehouses are down here. And what you'll basically see is that, interesting, that I don't remember GCP being there before.
Yeah, that's new since even, that's definitely new.
Yeah. Things are always changing. It's a fun time to be alive. So GCP. So it looks like GCP and AWS are both 35% more expensive than a standard warehouse. And then it is 25% more expensive on a standard warehouse. So the big question this raises is like, queries are running faster. Should you go and use them? Like, should you switch your workloads? Does the performance increase in, because you're billed per second in Snowflake, with a caveat, does the decrease in performance make up for the increase in cost? And I wouldn't say that always has to be the case. Like, I think it is important to note that, like, for some people, if you can just increase performance by 50% and maybe your cost goes up a tiny bit, like, that is magic. Like, that could be worth it for some people. If you compare the amount of time and engineering effort it would take to like tune your queries to run them 50% better. So I want to like put that thought in mind as we go through all these results. Like, not everything has to be a break even for it to make sense for your business. So that's an important thing for you to think about.
Can I interject here with one of the comments from the crowd here? So
Sure.
this person mentioned very specific hardware, and there is a blog article floating around out there, which is even influencing AI search results and stuff like that. But we're not so sure exactly what hardware Snowflake is using under the hood, because they don't tell us. Unless this person works at Snowflake, I'm not sure. But I just wanted to call out that there are articles where people are guessing this, but I don't know if there's facts around that or not.
Yeah, great call out. Like, it's not disclosed. And honestly, like, it doesn't matter, right? The point is they picked one of the new offerings, whether it's Gravitron 82 or 2, like, whatever. It doesn't like, your things are going to run faster, and here's what they're going to cost, and those are the facts that matter. So let's jump into that. I think actually maybe, Jeff, I'm going to pass it over to you. But one of the interesting things, like, I kind of naively, and I think a lot of people will probably do this math in their heads of like, oh, this thing's 35% more expensive. We're going to stick with AWS for the sake of today's call. But let's just say, like, 35% more expensive. I naively was like, hey, Jeff, when you're doing these tests, like, you need to make sure it's 35% faster in order to break even. And Jeff quickly schooled me with his math. So Jeff, I'll let you explain why that's not the case, and like, what is the actual way you calculate break even.
So the break even analysis is a little interesting here, because you are incurring the higher expense for a shorter amount of time. So in AWS, you actually only need 25.9% reduction in query time to offset the 35% costs. And in Azure, you need a 20% reduction in query time to offset the 25% increase in cost. And if you're like, hey, Jeff, your math is funny here, boom, I got the little calculation there for you. And then you can plug in some examples and make sure it's right. We do want to call out that every time you resume a warehouse in Snowflake, you are billed for 60 seconds. So if you run one query and it takes 30 seconds, and then you walk away from your desk and go to lunch or something, you're actually billed for an entire 60 seconds. So reducing a query running from 30 seconds to 15 seconds, you're still billed for the entire 60. And in this case, Gen 2 is going to cost you more, even though the query ran twice as fast. So 17 or 0.1017 credits compared to 0.023. And then moving on to the next two rows in that table below, it's like, we're trying to show you that on longer running workloads, you get more of a benefit. So on a query that runs for 500 seconds, you're only billed for the 500, and 250, 250. So therefore, now you are seeing the full benefit of Gen 2.
Yeah, and I think we're going to talk more about this, like, idle time in the future, because that will kind of, again, it all depends on how cost sensitive you are, right? So, like, as I mentioned earlier, like, for many people, it may just be worth, oh, you paid 10% more, 20% in a scenario where we'll see in many of the benchmarks, that's not the case. But even if you did pay 10% more, for some people, like, having dashboards run in half the time, that's totally worth it, even though this, like, idle time has gotten a bit more expensive. So we'll talk more about this later, but I think that is the something to keep in mind when it becomes a bit more confusing where you can't just look at like, did the performance decrease by this like break even that Jeff is showing? It's a combination of like, is the performance going to go up by that? And will your warehouse be like fully utilized, with these like longer running queries where you don't have this minimum billing period? So we'll talk more back about that later. I saw someone ask about receiving the slides. We'll be posting the recording, the slides, the blog post to our website later. So the answer is yes, plus more. All right, Jeff, do you want to quickly like spend a couple seconds just talking about how to use these things?
How do we call a warehouse or designate a warehouse as Gen2? So when you're creating a new warehouse, we have a new line of code here called resource constraint. It's a new parameter on the create statement, and you would just say standard Gen2. If you're confused by standard, so standard is as opposed to Snowpark optimized warehouses. So there's two types of kind of warehouses in Snowflake. Standard is the long known and loved one, but this is now standard Gen2. So you just add this resource constraint parameter when creating. And then if you want to alter an existing warehouse, same thing. It's just an alter statement and set resource constraint. That's it. Refer to Snowflake docs for more.
Yeah. Classic. All right.
Okay.
Let's dive into the benchmarking stuff.
Cool. So benchmarking. So Snowflake comes with the TCPH data set. So the data set with the -H is for analytical workloads. And then you can see that there's different scale factors. So within every Snowflake account, there's a Snowflake sample data database with these various schemas. So the _SF1, stands for scale factor 1. This has 6 million rows approximately in the largest table. And then it scales up by a factor of 10 for each schema that you're in, up to 6 billion rows for the largest one.
I never knew that stood for scale factor. That is a learning for me, but it makes sense.
I had to read the docs on this benchmarking data set to like make sure I was explaining it right. So it's totally. Yeah. I didn't know that at first either.
Jeff, there's actually a good question on this of like swapping out warehouses. I do remember reading something about this. Honestly, I wonder if we can just Google this really quickly. Because they talked about this in the docs of like when you change a warehouse size. Okay, here you go. You must suspend the warehouse before doing so. I wonder that. I feel like if you just did it, Snowflake will apply the change once it's been suspended. Like I don't think because if you have like a warehouse that's like running queries all the time and like you try and suspend it and then it resumes immediately, you'd get into this weird condition. So,
or would you get an error message? I guess we'd have to try.
Yeah, who knows? I think the answer is you have to try it. I'm sure the people at Snowflake have thought about this, and it's not going to like cancel queries or anything like that. I personally would just run this statement, and I imagine it will kick in once the warehouse has been suspended. So that would be my gut, but you can always try it out. All right, so that's the data set. We're going to repeat this message at the end, but like this is a benchmarking data set. Your data sets may be different and have different characteristics. Obviously, like Snowflake publishes this and a lot of other database vendors use this as a reference standpoint, but it is, it is kind of like a made up data set. So keep that in mind as we go through that, and we'll kind of reiterate that at the end.
Cool. So generally speaking, we benchmarked 3 types of scenarios. So building a DBT project, and this DBT project consists mostly of tables and tests. Then we did a bunch of select queries to simulate a BI workload. So we were hitting some of the larger tables, and we were aggregating the data or joining and then aggregating, stuff like that. And then finally, DML operations, merge, update, etc. So if you don't know, DML is by and large insert, update, delete. We did most of our testing on the update part of that, or merges including updates. So updates in isolation is just when you say like alter table, update column, and then set it equal to something. And then merges is when you're merging one data set into another, which traditionally would cause inserts, updates, and deletes potentially. But we focused most on the update aspect of that merge statement. So let's keep going there. Yeah. Oh, by the way, if you wanted to see the GitHub repository, you can either hit that URL or scan that QR code. In our blog post, you will see fully reproducible like steps that you can take if you wanted to do similar benchmarking yourself and get a DBT repo that sits on top of that benchmarking data set. Cool.
Awesome. All right, let's talk. So this is what you saw for the DBT build.
Yep. So combination of table models, which are CTAS queries. CTAS means create table as select, and then you have this select statement and it creates a table from it. So about 96, 98% of the workload that's done by this DBT project is spent creating the tables, and a very small percentage of the work is spent running the tests, which are select queries. So I think of this building this DBT project as really testing the performance of CTAS queries with a little bit of select stuff kind of going on in there. But what's cool is that I had my thread set really high to like 24 threads. So I'm actually putting a lot of concurrency on the database at this while doing this test, which is pretty cool.
Yeah, so I think that's a really good call out too. Like on your note of like, we're really testing CTAS queries here, but I do think it's important to like, I would guess like half of the Snowflake customer base, and same for BigQuery, is like using DBT, and there's some nuances with like, you have this other thing outside orchestrating these queries. So there could be like small gaps in when queries get submitted, et cetera. So I do think it is still an interesting test to run compared to just like, here's a creator, a CTAS query and just running that in isolation, just the sequence of them. But yeah, it is worth calling out, like most Snowflake customers using DBT, I would at least hope, don't have a project full of CTAS, like table only models. You probably have views in there and incremental models, which, well, views are actually interesting because they don't run on a warehouse. It's a compilation or cloud services query only. So like everything, benchmarks are different than, your benchmarking data will be different. And in this specific DBT project, it'll probably be very different than yours. So results may vary, but nonetheless, still an interesting thing to run.
Yeah. So here our first KPI is the number of seconds to build the DBT project. So it's impossible to sum up just the query execution time it's not impossible. It's very hard to do that. So we just said, what does DBT tell us as how long it took to build the project? And I would say that this particular benchmarking scenario had the most almost disappointing results, that it wasn't like extremely conclusive from a cost standpoint. But you could see that all queries or all builds ran faster by a significant amount, but not all of them hit the break even. And one thing that I'll call out here, well, a few more just call outs before we cruise on. So the XL warehouse that caused 11% cost delta, you'll see that this XL warehouse actually struggled throughout on the subsequent slides. And we did reach out to Snowflake about it, and they did see something going on in AWS with that warehouse. So you probably won't experience the same kind of performance degradation that we happen to be experiencing on the day that we were doing this. So
yeah,
and then the only
go ahead. I'll let you finish.
I would say the only other call out is the 4XL one consumed 9 credits, and this entire project I only consumed 18 credits. So when we look at grand totals later, just keep in mind that as we go through this presentation, whenever you see that a particular test consumed more than 1 credit, that's going to really weigh against the average a lot more than the rest of them. So go ahead, Ian.
Yeah. No, I was just going to say, like, on your point about the, like, oh, you see in the cost delta, there's this XL thing that's like the cost went up by 11%. Like, yeah, to your point, no one should walk away from this being like, XL warehouses on Gen 2 are more expensive. Like, no, this was a single instance of this single run of this single benchmarking data set where we observed this, potentially due to like networking issues or some underlying thing. So just want to like make sure that no one is walking away from this of like, oh my God, XL Gen 2 warehouses must be avoided at all costs. Not the case. Cool. And yeah, I will say this. So I think you made a comment like this, of all of the results, this was the most disappointing one. But keep in mind, relative, like we still got 30% increases, and in like many cases, it was cost savings, except for 2 of them. So like the lowest net performance and cost improvements relative to the other ones, still a very good like net outcome for Snowflake customers.
Yeah, thanks for adding more color there. Okay, so now we're on to our select only queries. And in the repo, if you go into the analysis folder, you can see the select queries I ran. So it's not part of the models, the core models folder in the repo. So here we got some pretty impressive savings, 30 to 55% reduction in execution time and 10 to 39% reduction in cost. All scenarios were a savings. And I think the numbers are pretty huge too. So let's go on to the next slide where we actually look at, actually, before we do, pop back one slide for 1 second. So just focus for a moment on row 3, extra small, 12 seconds and 5 seconds with a 42% savings. I want to dive into that one a little bit more and see what happened here. Okay. So here, when we look at the overview of the query profile, we see that Gen 1 ran in 2 steps and that Gen 2 ran in a single step. Okay, so in order to get this 57% time reduction and 42% cost reduction, we think, we don't know, but we think that this has a lot to do with software optimizations. And I believe the fact that 2 steps versus 1 step points very heavily towards a software optimization, more so than the hardware optimization.
Yeah, like Snowflake has clearly done something to change the way in which this query is executed. So I don't know if people have seen this before. If your query, and in the blog post, all of these will have like a hyperlink. So you can just like click on it and view the query in GitHub. If you look at the query for this one, it does have a subquery in it. And oftentimes, if you've noticed, when you run certain queries in Snowflake, you throw it at Snowflake, the query planner will decide, I need to first run this as an isolated step, and then I'm going to run that as run the rest of the query as another step. That often happens with subqueries. So that's what we saw going on in this query. And then when we ran it on Gen 2, it like automatically was like, I'm going to do this all in one go. And you see a huge uptick in performance and cost reduction as a result. So one of the themes of this, our learnings, is all queries will get baseline benefits from these hardware improvements, because just like table scans run quicker, and it is quicker to like process the data on the newer hardware and read from memory and blah, blah, blah. There's all this like baseline performance improvement, and then specific styles and queries appear to get an even further boost from these software optimizations. This is one of them.
Cool. So we broke DML down into 2 categories. One is just an update statement, where we're just like updating a column without joining in another data set. So we'll look at these results first. When I say targeted updates show enormous savings, I mean the updates with a filter. And you can see how I kind of designed the filter experiment in the lower right corner. It's like I'm just basically changing the value of one column, setting one column equal to the other just for one particular date of that data set. Overall, what's happening here is it updates 2.4 million rows on a 6 billion row table. So it's a very small percentage of the table is updated, even though it's like 2.4 million rows, still kind of a lot of rows that get updated. And you can see that updating with no filter, the first 2 rows in the top table, the performance gains are great and the cost gains are less than, I mean, they're like 4% increase in cost and 7% decrease in cost. So it's kind of like, it's not the most compelling story, but then when you look at the next 2 rows, it's an extremely compelling story that like we actually saved 79% on one of our queries. And that was the update with filter, and then updating a single row also had amazing results as well.
Yeah. So it's pretty interesting. We have some customers, and this is like a common use case for like GDPR, CCPA. Like if you got a request to be like, hey, I want you to wipe all the personal data you have on me, like a business's only choice is to go and run a update statement or a delete statement on the data set in Snowflake that targets those rows for that customer. So, this is a common use. So anyone doing that type of workload, there's like a clear, massive opportunity of just like take that workload and run it on a Gen2 warehouse. And as we'll see, and you'll likely be a very happy customer.
Yeah. So our friend and customer James says, as opposed to facts and figure, can we get some opinions too? And James, the opinions are coming at the end. So let's go through all the facts and figures, and we'll give you a little bit of color on how we're thinking about this. Cool. What cost opportunities? Let's see this question real quick.
I feel like we're going to cover this one later. I feel like we jump to it then. Yeah, we'll speed up a bit. I can tell people are hungry for like, just give us the takeaways.
Yeah.
So,
all right. So on one of the queries on the previous slide that had 79% cost savings, what we found by studying the query history table is that there was actually a 99% reduction in bytes written. And again, so this is pointing to software updates being absolutely huge in this cost reduction, more so than the hardware updates. So if you could see like the one query, okay, yeah, we'll keep going.
Sorry about that.
No, it's good.
I thought there was a query profile we had showing for this, but it's all good.
No, so I think just interest of time, let's keep going. But that's a really cool finding. I think that we had here was that the bytes written.
I'll answer this. The answer is no. Like, it's not using hybrid tables under the hood. So basically, what's important to note here when you do, I'm just going to skip ahead and see if we. Oh yeah, we do have the slide here talking about it. Okay, cool. Let's. I'm gonna add my thing I was gonna say on there.
Okay, cool.
So I'll let you just like cover this really quickly.
Okay, so before it was just like straight updating a single column, setting one value equal to another. This is now updating by merging. So a merge statement will join. Basically, you're merging a source into a target using a join. And so if we kind of look at the results here, merging with no filter, where we designed a scenario where every single row gets updated. That's not really a realistic scenario, but we still tested it. The results were mixed there with 15% cost delta, 15% savings and 22% not savings. And then as we start adding in filtered merges, the cost savings become a lot more clear. And again, this XL warehouse only had 7% savings, which was the XL warehouse was performing worse on that particular day due to some noise in AWS than the other warehouses were. So you could see this medium warehouse on that same experiment, like absolutely killed it, 44% savings and so on. So
yeah. So again, that like update, go ahead.
I was gonna say, now let's go on to the next slide. So you're good if you wanted to talk to this one.
Yeah, sure. Well, it's just like, again, the same. So again, merge is very similar to an update. The only difference is you do an additional table scan on this like new data you're merging in. So very similar results to what Jeff showed when he was like looking at the query profile for this. So this is like updating a small portion, like 100 over 600 million is a very small percentage. We see a big 43% time reduction, 24% cost reduction. Again, you see that same thing here with bytes written being like orders of magnitude lower on Gen2 warehouses. So if people have used Snowflake for a while, you've probably heard of like, don't treat it like a transactional database. Don't do like lots of frequent small updates. The reason behind that is because when you update micropartitions, the files that Snowflake stores its native tables in are heavily compressed files. So like a single micropartition can contain, like, in theory, it could have like hundreds of thousands or even a million records in one 16 megabyte compressed micropartition. So when you do like update order date, like for that one customer, that one order, you are rewriting an entire micropartition. A single update is actually affecting like potentially a million records. So what may be going on here is software optimizations targeting how much data needs to get rewritten when you do these small updates. So this is something we'll kind of come back to at the end of like an interesting area. We saw big improvements. Jeff, I'll let you like summarize the aggregated results, and then we can, we're almost at the final kind of takeaways that we can give to everyone. Oh, you're muted, Jeff.
Thank you, sir. So just first, a word of caution when viewing aggregated results on very small sample sizes, especially where we didn't run the same number of experiments on each one of the warehouses, et cetera. It's still useful to kind of aggregate them, but don't interpret this as expected performance. So one of the things I'll call out right away was that 2XL that costs 13% more. We're not saying, like, don't walk away from this saying, oh, 2XL is not going to be a performance increase. And we also talked at length about the XL warehouse kind of lagging as well. It's just a smaller sample size, and noise in AWS kind of influences the aggregate here. But what can we kind of conclude here? I think that we can conclude that select queries gaining a 46% like performance boost and a 26% cost savings. I think that's huge. It's kind of like a takeaway to walk away with. And then filtered DML is way outperforming unfiltered DML for all of the reasons which we already discussed. So I think that was pretty cool to see.
Yeah. I mean, the big thing for me is I just stare at this and like most of the stuff is to the left, which is like across all these tests, cost is going down, performance is going down, which is huge. Now, I think the important thing to talk about when giving these results is when you were calculating those costs, Jeff, you were just saying number of seconds ran, what's the cost of those? Like if it ran for 8 seconds, how much was 8 seconds of compute cost? If it ran for 4 seconds, how much does 4 seconds of compute cost? What's the delta? So maybe tell the audience a bit of why that's important.
Okay. So in the beginning, we talked about the 60-second like kind of minimum billing period. But then in addition to that, you also have an auto suspend time that you put on your warehouse. And the best practitioners will set that to 60 seconds. Some practitioners will leave that to the default of 5 or 10 minutes. But let's just assume that you have your auto suspend set to 60 seconds. That means even queries that run for 10 minutes will actually most likely, if there's no other work happening, just say it's an isolated query all by itself, it will probably incur 11 minutes of billing because you get that 60-second kind of idle time at the end. So we did a little bit of math here just so you could see it in a table. And the whole point is that for longer workloads, this 60-second auto suspend time has a diminishing impact on the overall result of your performance improvement. So this table is just saying, hey, let's assume that the queries run twice as fast on Gen 2, which they might not always. We want to keep it very simple to digest. When do you actually break even? It's somewhere around that 120-second mark. If you're going to also consider that you're going to get 60 seconds of idle time after the query.
Yeah. So I think my thing I'd say to the audience here is like, if you're extremely cost conscious, and can't afford a single dollar increase in your Snowflake bill, then probably avoid flipping this on a BI warehouse, for example, because BI warehouses will naturally have lots of idle time because queries, it'd be bad if they had low idle time because that means your queries are taking like minutes to run, right? So BI warehouses will not typically be fully saturated. You will have more periods where in between queries running, the warehouse is sitting idle, and the mental model is like, even though the queries are running for less time, that idle time has now become more expensive. So that's just a thing to consider. I think we're going to talk about this on the next slide, actually. Yeah, I guess maybe I'll go through a few things, Jeff, and then you can kind of jump in. Like, one, what's absolutely crazy is Snowflake just gave us this brand new 0 effort knob that boosts performance and results in cost savings most of the time. Jeff, in his experiment saw like select queries and DML queries. So like targeted updates where you're updating a small proportion of the table had huge performance gains. Was, where we went even further, or where we saw even further cost and performance benefits. But I think like across the key thing is like across the board, there were still good results. Just some had like even better results than others. Jeff, do you want to comment on like CTAS queries had less gains? I think you, from a performance standpoint, or from I guess both performance and cost?
For both. Yeah. The results on the building a DBT project that had only tables in it was pretty mixed. And so that's just, it's usually faster, but it's not always less expensive. So that's why I just said consider those carefully.
Yeah. So I think that goes into the next 2 bullet points. Well, like we've given some suggestions on where you will most likely see really high cost and performance improvements. But at the end of the day, I'm going to butcher this. I forget the quote from someone we talked to at Snowflake.
I got your
Go
back.
ahead.
I got your back. The quote is, the benchmark only tells you how fast the benchmark ran.
Yeah, there you go. So that's the only thing benchmarks are good for, is telling you how the benchmark performed, which may or may not be how your thing performed. So we were running isolated queries on these warehouses, right? So we weren't accounting for things like concurrency. We're running them on the benchmarking data set, not your data set. So you should go test this on your actual warehouses to make any conclusion. It is an incredibly easy test to run. You literally run this alter command and you can watch your warehouse in the Snowflake UI or a cost management product and just see the delta in cost and trend your average query performance. And you can make these decisions very quickly. It's a very safe experiment to run because your queries are going to run way faster, right? So your user obviously gonna get a better experience. And then, worst case, you for a few days, you spent maybe 5% more. So it's I would be, the second this comes to GCP, which our Snowflake runs on, I'm going to be turning this on all of our warehouses and then trying it out. On that topic of idle time, Jeff had a good point here of if you're thinking about where to start, target the if you want to be super cautious, target the long running warehouses with long running workloads. So your ETL jobs, your DBT projects, your data ingestion jobs, those will, you're not going to have to worry about this potential idle time, eating into your improved performance cost reductions. Arthur, that's awesome to hear. You've been running this. I'm going to Slack you later for for the results. And then I think, Jeff, you had this great point, which someone,
this question here corresponds
this
to
one. Oh, sorry, we're clicking the same thing. This one, right? Oh, wait, no. There was this one from Samar.
Samar.
Is downsizing possible? Yeah.
Samar, thanks for the question. And I'd like to speak to this for a moment here. It's actually the last bullet point on the slide. So I think of this as hey, this t-shirt I'm wearing right now, it's a large, but it's a little tight on me, but an extra large would be a little bit baggy on me, right? So what if there was something between a large and an extra large that I could just go to right away? And also considering that, coming back to Snowflake and not my t-shirt, going from a large to an extra large is going to cost you twice as much. But going from a large Gen 1 to a large Gen 2 is only going to cost you 35% more. So, and we did see that some of the queries run in half the time, just like you would expect from making that full step. So I would say yes, absolutely. You can do this as, if you think that you need to scale up to the next size, before scaling up to the next size, just go from Gen 1 to Gen 2 first and see if that meets your needs. And then if you need a little bit more power, then go up to the next size. I think your question was phrased the opposite, but the meaning is still there. It's still the same.
Yeah, it's a new lever. You can use it on your existing warehouse, or next time you're thinking about bumping the size, consider just changing the addition. And similarly, you can change the addition and drop a size and potentially have huge cost savings at no performance impact. So it's opens up a lot of exciting kind of new possibilities. And I think with that, we'll wrap up. One, as a owner of a software business, I can't not plug our product. So obviously a lot of people on this webinar, I assume, care about cost management and Snowflake optimization. So if you're not aware, Jeff and I don't just post about Snowflake costs. We also work with close to 200 customers now, helping them optimize and manage their Snowflake costs. So we have a team of engineers who is every day, every week, keeping up with new Snowflake releases, building those as insights into our product to help you understand where you can apply these different best practices. And so if you are interested in learning more about that, you can go to select.dev/demo. You will get to, I don't know if this is a selling point or not, you get to talk to me I think I'm a pretty cool salesperson. So that is a bit about Select and what we do. Just to wrap up on this results and webinar, we're going to be publishing this on our site, along with the recording, the slides, and a full kind of write-up Jeff did where we talk about all these things. So thank you everyone for listening. And oh, you know what? There's one comment here that question that Jason just asked, which I think is actually a great one that we didn't address. If you have multi-cluster warehouses, how can we think about the impact on that? And Jason, what I would say here, this is kind of one of those things where you're just going to have to test it. But how Snowflake's multi-cluster warehouses work is once the warehouse is starting to queue because it can't keep up with the queries, after a certain amount of queuing, it will spin up another cluster. And if there's more queuing, it'll then spin up more clusters to try and get through all those queries and eliminate the queuing. So what would happen if you just flipped this multi-cluster warehouse from Gen 1 to Gen 2? Well, all the queries are going to now run faster, which means you have more throughput through the warehouse. And as a result, Snowflake may not need to scale up as many clusters. So actually you don't need to, in my opinion, you don't need to do anything here. Like you would just turn on the Gen 2 warehouse. I don't think you need to like fiddle with your max cluster count. Although in theory, you could probably reduce it now, because what I suspect you'll see is that Snowflake doesn't have to scale up as many clusters as often because the throughput has increased. It is now processing queries much faster. So I think that is kind of an interesting, in addition to like, hey, this is now a mechanism for changing the size. Perhaps it's a mechanism for you may not need as much horizontal scaling.
Yeah, and then you're getting order of magnitudes cost benefit, right? Because when it has to scale horizontally and turn on another cluster, you're now paying twice as much. So if you're going to actually avoid it to turn on another cluster, you're actually avoiding like paying 100% more for that same time period, which is really cool.
Yeah, and so that would be a cool one to test. Very hard to actually simulate, because we'd have to, I mean, maybe we should do this sometime, but you'd have to like have a program that's like hammering a warehouse with queries, and then you do the same kind of experiment. So maybe someone who's listening, who's looking for a fun activity on the weekend, that would be a very cool experiment to run, and we'd love to hear it, or hear what you find. Awesome. Okay, I think we've covered most of the things, and I know we're almost at the hour, so let's call it. Again, don't hesitate to reach out to us if you have any questions. We'll be publishing this on our site, and if you're interested in learning more about what you can do to lower costs and manage costs on Snowflake and performance, please reach out. We'd love to chat. All right. Thanks, Jeff. I'll talk to you in
Ian.
Slack.
Thanks, everyone. Talk to you
Bye.
soon. Bye. Okay.